Here is our topic. Here's our objective. And by dispersal, it's like spread out. All right. Another way to think of this is if I had a solid and a gas and I change it, what's going to happen to entropy? And you want to be able to, at the end of this video, just say, hey, it's going to do this. Here's our definition of entropy. Its unit is joules per degree Kelvin, joules per degree Kelvin, and its symbol is S. Now, I want to give you an analogy. Molarity is to concentration as entropy is to microstates. These two words, I think, are a better way to describe what these things are. And molarity is essentially a concentration, how much of this and that. Microstates are like different ways for the system to be, but the overall system doesn't change. The macro state of it doesn't change. And here's a visual to help you see that analogy. If I had a box and I had two things in it, and I increase the concentration of the number of oranges or purple in there, number of circles, my molarity is going to increase. So this is like a visual for molarity. Entropy or microstates, if I increase the box I've got one particle and then I put it in a bigger particle, one particle in a box and I put it in a bigger box, the second box is going to have more microstates because there's a lot more places for this ball to be. All right. That's our analogy. All right, let's look at entropy and what it's related to, what affects it. The first off is volume. Well, if I had a gas in a box and I increase the box, am I increasing or decreasing my amount of microstates? Well, I'm going to increase it because there's lots of different spots for the ball to be over here, where I had less options over here. Now, would be at a constant this is constant. Nothing else is changing, like temperature. It wouldn't be changing in this regard or in this example. Now, what if I do increase the temperature? All right, so I have three particles at a low temperature, and I increase the temperature. Well, you'll know some are going to speed up. You can see some of these sped up. One didn't change. However, there's another subtle thing that goes on with when you increase the temperature with a gas, in that you get the particles move faster, but all at once. If you look at it, collect the system collectively, you're going to have a greater variance in the speed of the particles, as we've seen in the Maxwell-Boltzmann distribution. And that's sort of what this is getting at. If you look at a cold gas, and I see this as blue, this first big hump, the particles don't have a wide range, but with a hot gas, they have a really wide range. Therefore, this will increase the entropy when I increase the temperature. I'm giving them a lot of different ways to know themselves. You can see I've got one going really slow and really fast, and then moderate. And same thing here, where these ones, they're all going relatively the same temperature. And that's these two ones on the right tend to are this red. That's how that relationship works. Now, for phase, when I go from a solid to a liquid to a gas, what happens to entropy? Well, think about microstates. Where do I have the most ways for the system to be the same on a micro level, but overall not change? It's the gas phase, because they're vibrating in place, but now as a liquid, they can, jockey a little bit around, like maybe, go see their neighbor, check their spot out. But as a gas, they can be anywhere in the container. Our final one is number of particles. Let's say I had a gas made of two different things and I separated them through a chemical reaction. What's going to happen to entropy? Well, where is there going to be more microstates? Definitely the one on the right, because I've got more things buzzing around. There's going to be more ways for the system to like be the same, but overall not change. So the number of moles of gas, as that increases, so does entropy. All right. Now, to summarize it, the more options, the more random, the more energy. And you can affect this by temperature, not pressure, changing the volume, changing the number of moles of gas, and the number of phase chains. You're going to increase the entropy. And this is where I got the Maxwell Boltzmann graph. Thank you. Have a good day.